Okay, so it's like why is there part two with a totally different thing, right? Okay, so a different simple harmonic oscillator has a period of 2.8 seconds, amplitude of 3.4 meters. Write the equation for its position, write an equation for its velocity. Well, let's assume it starts in the middle going up, right? So its motion is like up, down, up, right? Its sine. Okay, so it's x is equal to x naught sine omega t. Well, let's see, the amplitude is x naught, so that's 3.4, right? Okay, sine of, and then omega is going to be, it does it every 2.8 seconds, right? So omega is 2 pi divided by 2.8, right? So 2 times pi divided by 2.8, 2.24399, 2.24399 radians per second. Now, the sad thing is that we have two sig figs, right? So presumably we'd say 2.2. I refuse to round that. 2.234. Whoops, 24. Dyslexics should not teach physics, right? 399. That's a 4. That's a 3. Oh my God, it's a total wreck, right? 3.4 meters sine of 2.24399 times t, right? And that's this guy here, right? Ta-da. Okay. And then find the equation for its velocity versus time, right? That's our x, right? Okay, so we got to find its velocity is, of course, going to be v naught cos omega t. So I'm just looking at the formulas in the data packet, right? Okay, we got to find what v naught is, and of course, v naught we're going to get from this formula, right? Omega square root of x naught squared minus x squared, right? To get the maximum velocity, you make this guy 0. So of course it's omega x naught, right? And so it's going to be 3.4 times this guy, right? So times 3.4, and you get 7.629. Now, if you do this guy times this guy, this rounded value times this, you don't get 7.6. But if you use the unrounded one, right, times that, which is what you should do, right, then you get this, right? So it's going to equal, v is equal to 7.6 to, I'll just say 629, right? Cos of, and then of course it's 2.24, I'll go 2.24, 4, right? T, like that. So 7.6 cos 2.2 t.